What part? What's the part for?
It's a part for one of the lasers that we're building.
You're building a laser?
Uh-huh.
Yep. They said lasers. Lasers. Oklahoma Robotics invited us out for a tour. If you have an idea but need help making it a reality, this is the place for you. They are an engineering and design team with mechanical, electronic, software, and automation skills. They also have a shop to build prototypes or make small production runs. They help everyone from startups with no R&D team at all to established companies that just need some extra help. It's a really cool place. Let me show you some of the things that we saw. They have multiple 3D printers. With these, they can print parts for prototypes or production. Like this part that goes on a device that mimics the sound of fish feeding. Fishermen use it to attract fish. Or this housing for controls for a vehicle rooftop-mounted thermal image camera used for hog hunting. Oklahoma Robotics built the controller that provides easy operation of the camera from the cab, including power, zoom, tilt, and variable speed pan. I got to see how they design, test, and build the circuit boards used in the controller. They use lots of parts and some of them are teeny tiny. This part is called the resistor, and we use the diagonal microscope to get a good look at it. They couldn't tell us what some of their designs are being used for. They take confidentiality agreements very serious. So while we don't know what the self-leveling platform will be used for, they could show us how it worked. Anytime the horizontal part went out of level, the legs automatically adjusted to make it level again. It's only the testing phase, but it's already super cool. They even let me try it.
Lift it and do it slowly, and it'll adjust.
Wow.
We also saw a circuit board design for an inspection sensor array that self-adjusts for lighting conditions, a 3-phase motor controller for an industrial plumbing snake, how microprocessors are programmed, 3D CAD designing and modeling of parts and machines, how they design control panels and make wiring diagrams, what the control panels look like when they are built, and some mechanical projects they build, like this self-centering welding jig. Machines like this CNC mill that they use to shape metal can hold tolerances of 1/1000th of an inch. To give you an idea of what that means, this piece of paper is almost 4/1000ths of an inch.
Walking through, we saw how they designed this part on the computer, where they build it, what it looks like built, and then where it goes on the assembly of the machine. The super cool 5-axis laser cutting machine. You're gonna want to see this. But first, let me show you one other project. Ever been with your mom or dad to exchange propane tanks? It's kind of a pain. You can't take the propane tank inside, and the store employee has to meet you outside. Usually someone doesn't have a key. It's not fun for you or either the store.
Enter the automated propane exchange station. It may not be as cool as lasers, but there's a lot going on here that makes life better for everyone. For the consumer, it's much faster. Just walk up and make your transaction. Credit card processing handles payment. The machine opens doors to accept your empty tank. Then it opens another door, allowing you to take a filled tank. Cameras, scales, and other features ensure a safe and accurate transaction for everyone. For the store, they no longer have to disrupt an employee to make the exchange. Plus, inventory is continually tracked. The supplier receives inventory reports and knows when it's time to come pick up empty tanks and restock full tanks. This makes stocking trips more efficient. This mix of mechanical, electronic, and human design elements is a win for everyone. That makes it pretty cool, even if it doesn't have a laser. What is a laser anyway?
A laser is a highly focused beam of light. That beam carries energy, and that can be used to do something as simple as shining a dot on a surface, which uses a small amount of energy. Or laser can cut through metal, like for 2.5 inches thick stainless steel, which uses a lot more power. The laser on this machine is powered to cut through medical-grade plastic.
These custom-formed mouth trays are an alternative for braces used for straightening teeth. A patient would receive a series of these custom-fitted trays to gradually move their teeth into the desired position. But cutting away the excess material on the trays is very time-consuming, and it must be done precisely, or it can affect how comfortable they are to wear. Off-the-shelf laser cutting machines aren't designed for the high-volume production needed. To address these problems, the client partnered with Oklahoma Robotics to construct a heavy-use, 5-axis laser cutting machine. The skills and processes that you saw earlier all come together in the design of this machine. There are sophisticated mechanical parts, intricate controls, custom circuit boards, integration of standard electrical components, and thoughtful human interface design packaged into this powerful machine. This machine was in the final stages of completion, so we didn't see it run, but we did get to see another laser they built in action.
This laser can cut many materials such as wood, leather, and plastic. It can also engrave metal. It was built right here at the Oklahoma Robotics. To show me how it worked, they asked me what video game I like to play. I said Minecraft.
They found a creeper with the Minecraft logo, and the operator used it to program the laser with a few clicks and tweaks. They put a scrap piece of wood on the cutting table, and the camera system immediately recognized it and put the boundaries on the screen.
The operator let the laser go to work, and in just a couple of minutes I had a Minecraft souvenir, and my friend had Pikachu. To cap off our visit, we even played arcade games and on a console one of the employees made for fun. We saw a lot on our visit. Everyone I met was friendly and eager to teach me. Thanks, Oklahoma Robotics.